Welcome back, dear students. Now I am here with the second part of light reflection and refraction. So in the first part, I've already explain you about the spherical mirror and the four rays that are used to make the ray diagram. The first ray is if any ray is parallel to principal axis, then it goes from the focus after reflection. The second ray, if any ray is come through the focus, then it becomes the parallel to the focus principal axis after reflection. The third, if any ray is incident through the or is come through the center of curvature, then it goes in the same direction. And the fourth, if any ray is incident obliquely at the pole, making some angle, then it reflects back with making the same angle. So now I'm going to explain you about the image formation by a concave mirror when object is at infinity. So you can see this is the concave mirror, principal focus, and so when the object is at infinity, the parallel rays are coming from these, and that rays are goes from the principal focus, and the object is a position of image is at f. Image of nature of the image is virtual and real and inverted, and the size is very small and highly diminished. Second, when the object AO is placed beyond the C and to F, beyond C means it is a backside of the C object. You can see OA is an object which is placed beyond C. Then we will take a first ray that goes parallel to the principal axis, and it goes in the through the focus F. And if the ray is passing through the center of curvature, then it reflects back in the center of curvature direction. And now you can see the position of the image between C and F, and nature of image is real and inverted, and size of image is smaller than the object. When object is placed at C, so now I am place the object at the point C. You can see here light rays, and then it goes from the focus, and if any rays goes through the focus, then it becomes the parallel to the principal axis, and the image formation is just beyond the C. At C, you can see position of the image at C, nature of image real and inverted, size of image same size as that of the object. So C in the center of curvature is that point at which point the image is of the same size. Real and inverted means real because they are the light rays are actually meet at these points. That's why this make an real image. And inverted means you can see if it is pointing in upward direction, then the image is in pointing downward direction. That's why it is the inverted image. Now the fourth position, when the object AO is placed between C and F. So now you can see object is placed between C and F, and now we are taking the two rays. When the first ray is goes parallel to the principal axis, it goes back through the F, and second when it is through the C, and then it is also come back from the C. So these two rays are make an angle IB, and image is there. It is the big size of the it is the large size to the object, and it is beyond the C. So position of image is beyond C, nature of image real and inverted, size of the image larger than the object. The fifth position, when object is placed at F. So when our object is at F, we are also taking two rays. One is parallel to principal axis, it goes through the F, and second is center of curvature, and it goes through the center of curvature. These rays become the parallel, and they are meet at the infinity, so image is formed at the infinity. When the object is placed at infinity, image formed at infinity, nature of image real and inverted, size of image is very large. Second, now when the object is placed between focus and pole, actually this is P, F and P. Now you can see this is not O, this is P, and principal focus se gayi, and this is reflected through the focus. parallel to the principal axis, and second ray we are taking the through the center of curvature. These rays are not going to meet in with each other in a forward direction, so we just draw them in backward direction. So here I make an eye so that you can see that observer can see that these rays are coming through this point. That's why the image are forming here, and this image is the virtual and erect image. Now you can understand what is the difference between real and inverted and virtual and erect. So I am going to explain you about through this example. You can see O is the pointing upward and I is the pointing upward. So you can see I is the image of point O and B is the image of point A. So this is the erect image. Erect means if it is the pointing upward, the image is also pointing upward. But the last, for example, you can see if the image is pointing up, object is pointing upward, the image is pointing in the downward direction. That's why they are the inverted images, and this is the erect image. Virtual image, just because it is just behind of the mirror, image formed behind of the mirror. That's why this is the virtual image, and the size of the image is larger than the object. Now I make an table for the easiness. So you can see all the 6 parts here. When the object is at infinity, position of the image is at F, highly diminished, real and inverted. So I make the table for all the 6 parts of that uh, formation. Now image formation by convex mirror. You can see this is a convex mirror. So first position when the object is between the P and infinity. So OA is the position. We are taking the first ray that is a parallel to the principal axis, and actually basically this is the this here. So it goes from the focus, and second ray is goes from the center of curvature. Image formation is between P and F. You can see here image is formed between P and F. So position of image behind the mirror, virtual and erect, size of image is smaller than the object. Second position is at infinity. When the object is at infinity, also that time also the object position of image is at F, highly diminished, virtual and erect. These are the two position of the image formation by a convex mirror. Uses of concave mirror. Concave mirror are used in torch, searchlight and highlights. They are used as the shaving mirror. They are used by the dentist to see the large image of teeth. Large concave mirror are used to concentrate the sunlight to produce the heat in solar factories. Now, the some uses of the convex mirror. Convex mirror are used as the rear view mirrors because it covers the large area, because it makes the diminished image of an object, and the opposite to the concave mirror makes the large image. That's why it is used by the dentist. Secondly, they are used as the magic mirror and to form the funny images. Sign convention for the spherical mirrors. So you can see here, object is placed to the left of the mirror always. If for the concave and convex mirror, that's why the incident rays from the object always move from left to right. All the distance parallel to the principal axis are measured from the pole of the mirror. Number 3, all the distance measured to the right of the pole, that are the positive axis, while taken the positive, and the left to the pole. यानी कि so I will going to explain you with this example with a picture. This is a concave mirror. You can see here this is the pole, and I draw the x and x axis, y and y dash. So firstly I will going to show you. Now you can see the direction of incident is left to right. So left to right all the things are taken positive, and right to left are taken negative. In upper direction the distance are positive, and negative in the downward direction they are taken as negative. Similarly for the convex mirror, similarly you can see here for the convex mirror, if we are going to take the from the pole, the right side distances are positive, left side distance are negative, upward is positive and downward is negative. Now the next topic is mirror formula. Mirror formula is 1 upon b plus 1 upon u equals to 1 upon f, where b is the distance of image from the pole, u is the distance of image from the pole, and f is the focal length of the image. U is the object image distance and focal length of the mirror. Magnification produced by a mirror is defined as the ratio of the size of image to the size of object. So m equals to h dash upon h. It means the height of image upon the height of object. there is another formula minus ka b upon u to explain the magnification. Okay, so thank you so much. More of the reflection we are going to consider in higher classes.